All right, we're looking at slope and linear equations. Slope and linear equations. Slope is rise over run. Slope tells you how steep something is. Like suppose here's this mountain and there's a ski slope right here. Here's this guy skiing, okay? He's coming down the hill. Okay, you can see this hill here looks like it's pretty steep, you know, for skiing. Here's another one, and you know, this guy here, he's skiing too, but his hill doesn't look as steep as this one. Slope helps us describe how steep a slope is. This is steeper than that one. It's the rise over the run. Rise is how high it goes. Run is how far over it goes. So we can see in two lines right here. Okay, here's a point, and here's a point. And we could see the slope of this line right here. You can see that it, from this point to that point, it rises 1, 2, it goes up 3. That's my rise. But it goes over 2. So my slope of this line is 3 over 2. Versus this one here. Here's another one. Here's a point, and here's one. And if I draw this line right here, you can see it's not nearly as steep as that one is. But if you look at this point to that point, it rises 1. But it runs, let's see, 1, 2, it looks like it runs 3. And there's my slope of that line, which 1/3 is not as much as 3/2. 3/2 is a steeper slope and a higher number than 1/3 is. 1/3 slope is not as steep as 3/2. So this is what slope is. Now, if you have 2 points, like suppose you have this, 3, 5, and 2, 7, negative 7, okay? And you want to find the slope of these. Well, you can graph them if you want to. 1, 2, 3, 1, 2, 3, 4, 5 would be right there. Then -2 and then 7 would be right here. And so here's this line right there. Okay, what's the slope of that line? Well, this one looks like it goes down 2. And then it goes over 1, 2, 3, 4, 5. So that'd be -2/5. Okay, but graphing it and doing all that stuff takes a lot more time than if you do what's called the slope formula. This is the slope formula, the y in point 2 minus the y in point 1 divided by the x in point 2 minus the x in point 1. And so we can do this right here and find the slope that we just did using these 2 points. So what I do is, see, there's 2 points here. So this one here, we'll call it point 1. This one here, we'll call it point 2. All right, so I take the y in point 2, which is this 7. See, it's x and then y, x and then y. So my y in point 2 is 7. So if I'm doing the slope formula for this, the y in point 2 would be 7 minus the y over here in point 1 is 5. On the bottom, the x in point 2, well, that's -2 minus the x in point 1, which is 3. And so 7 minus 5 is 2. -2 minus 3 is -5. And there you go, it's -2 over 5. Now see how my negative is in the bottom? That doesn't matter. See here, look, -2 over 5 is the same as 2 over -5, which is the same as negative out front, 2 over 5. All 3 of these are the same thing. There's no difference. The negative could be at the top, it could be at the bottom, or it could just be out front. All those are the same. But this is how you find slope. Okay? So now do a couple more maybe. Like suppose I have 7, 8, and 1, 3. Okay, what's the slope of this? All right, we'll just use a slope formula. Again, it's y from point 2 minus the y in point 1, x in point 2 minus the x in point 1. So in this one, my slope, and m is the letter we have represent slope. The y in point 2 is 3 minus the y in point 1, well, that's 8. So that's 3 minus 8 on top. The x in point 2, well, that's this 1 right here. minus the x in point 1. Well, that's 7. So there's my slope there. 3 minus 8 would be negative 5. 1 minus 7 is negative 6. And the negatives can cancel, so it's just 5, 6. Okay? Now, a couple things to know. There's two special kinds of lines. We have what's called zero slope or no slope. And then we have undefined slope. No slope and undefined slope. No slope is when we do this right here and find the slope, we get 0 over some number, 0 on top, like 5, which means this has no rise. It has no rise, it just has run, which means like this right here. If I take these 2 points right here, if I go from this point to that point, well, it does not rise. It has 0 rise, but it has run 1, 2, 3, 4. Oh, this is supposed to be 5, so let's put another one there. 5. 1, 2, 3, 4, 5. This has no slope. So a flat line like this right here is a 0 slope or no slope. Now, undefined line would be like if you have 0 on the bottom, which would look like this right here. These 2 points here, and it forms a vertical line. See here, my rise from this point to that point, it goes up 3. Okay, but it has no run, which means the run is 0. So the 0 being on the bottom makes it undefined, which is a vertical line. So no slope, 0 slope is a horizontal line. This is horizontal. And 0 on the bottom is undefined, which means it's vertical. Okay, so those are two things you have to watch out for. So suppose you have this then. Suppose you have these 2 points. 5, 3, negative 2, 3. What's the slope here? All right, well, if I do my slope formula, I'll write it down again. Y from point 2 minus y from point 1, x from point 2 minus x from point 1. All right, the y in point 2 right there is 3. So my slope is going to be 3 minus the y in point 1. Well, that's 3. The x in point 2 right there, negative 2, minus the x in point 1 is 5. So if I do 3 minus 3, that's 0. Negative 2 minus 5 is negative 7. But see how I got 0 on the top? 0 on the top means there's no slope. There's no slope on it. It's a horizontal line. Okay? Here's another one. Suppose I have, I don't know, 6, 7, and 6, negative 1. What's the slope here? All right. I'm going to do negative 1 minus 7 on top. I'm going to do 6 minus 6 on the bottom. Negative 1 minus 7 is negative 8. 6 minus 6 is 0. And see, I've got 0 on the bottom. This right here is undefined. It's going to be a vertical line because the 0 is on the bottom, which means it has no run. If I graph these, it probably makes more sense if I graph them. Look here, 6, 7. Let's see here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 is right here. And then 6, negative 1 is right there. And see if I connect them. Look at the vertical line there. See, it's undefined. Go back to this one. If I graph it, I'll just make a graph right here real quick. 5, 3, 1, 2, 3, 4, 5. 1, 2, 3 is right there. And then negative 2, 3, negative 2, 3 would be there. And then there you go, look. It's a horizontal line, just like we said it was. So that's some things to remember when you find slope of lines. You've got those two special kinds. If you end up with a 0 on the top, it's no slope, which is horizontal. Or if you have 0 on the bottom, that's undefined, which is vertical. Okay? Otherwise, this is your slope. If it's negative, like if you have a slope of negative 2/3, it's going to go down 2, and it's going to go over 3. So that would look like this. Just say you have a point, it goes down 2, and it goes over 1, 2, 3. And it'd be a slope that looks like that. That's negative 2/3. Okay, so that's how you find slopes of lines. Now, we do have what's called parallel lines. If you have parallel lines, they look like this right here. these are parallel lines. They have the same slope. They're parallel. They will never intersect. Well, see here, look here. This goes up 2, and it goes over 1, 2, 3. The slope here is 2/3. Well, look at this one. It goes up 2, and it goes over 1, 2, 3. It also has 2/3. So if the slopes match, they're parallel lines. Because they do the same thing. They go up 2 over 3, up 2 over 3, and they'll never intersect. Now, if they don't do the same, then they're going to intersect probably. Or they will. If the slopes are not the same, they have to intersect. Okay? Now, we also have what's called perpendicular. Now, perpendicular is when you have two lines that intersect and they form a right angle. That's kind of a special deal because like when we build buildings and things, we make our walls at perpendicular angles, at right angles. So they're stronger and they last longer. So perpendicular is kind of a big deal. All right, well, when you have perpendicular lines, they have this special kind of thing. They have what's called negative reciprocals. Like suppose one slope is 2/3. Then the one that's perpendicular to it, it'll be flipped and will be the opposite sign, which means it'll be -3/2. These are perpendicular of each other. 2/3, -3/2. This one's positive, this one's negative. This is 2/3, and this is flipped, 3/2. Those are perpendicular lines. Okay, this picture here, I didn't draw it very well. Let me draw another one. Okay, here's another one. These are perpendicular. Okay, if I look at this one, see it goes up 2, and it goes over 3. See there? That's this one. It goes up 2 and over 3. All right, look at this one. This one goes down 1, 2, 3, and over 1, 2. See, it goes down 3/2. They're perpendicular. If they didn't have that quality, they would not form a right angle. Okay, so now, like 3/5. What would be perpendicular to 3/5? Well, it'd have to be negative, and I flip them 5/3. What about -1/4? What would be perpendicular to that? Well, it'd have to be positive. It'd have to be positive, and I would flip that 4/1, which is 4. Okay. What about -3/7? What would be perpendicular to that? Well, it'd have to be positive because it's the opposite, and I flip it 7/3. And these are how you find perpendiculars. Okay. All right. So we have this assignment here we're working on, and it says use the slope formula to determine if the lines passing through the given pairs of points are parallel, perpendicular, or neither. So you're going to find the slope of these two. You're going to find the slope of those two, and you're going to compare them. Get it on the screen here, huh? You're going to find the slope of these, find the slope of those, and compare them. So if I do this one, all right, I'm going to go 6 minus 3 on top. On the bottom, 7 minus 5. 6 minus 3 is 3. 7 minus 5 is 2. There's the slope there. Okay, now do this one. I'm going to do 8 minus 5 on top. I'm going to do 2 minus 4 on the bottom. 8 minus 5 is 3. 2 minus 4 is -2. Okay, they are opposites, but these are not perpendicular because they're not flipped. So this is neither. This is neither. Okay, so you do this on each one, and if they're the same, if they're exactly the same, that means they're parallel. But if they're, this is called negative reciprocal. If they're negative reciprocals, like this right here, they'll be perpendicular. And if they're not either one of those, then it's neither. Okay? So that's how you tell about the slopes a little bit. Okay? Now, let's look at some lines. Okay, we're going to do some linear equations. We have two kinds of equations that we're going to be looking at. We're going to have what's called slope-intercept form, and we got standard form. Okay, two different forms. Slope-intercept form looks like this: y equals mx plus b. Right here, this number is the slope. M is the slope, as we just talked about, and this b right here represents the y-intercept, which means that's the point on the y-axis here that the line crosses through. So like on this one, looks like 3. Looks like the y-intercept would be 3 there because it crosses at 3. Okay. Standard form, you just have some number times x plus some number times y equals some number. A, b, and c are just numbers. But the thing about these numbers, there's no fractions, and a is always positive. None of these numbers can be fractions, and a has to be positive. So that's how you do a standard form. Okay, now suppose you here's problem number 1. Suppose we want to do slope-intercept form, and we want to know what the equation is of the line that has a slope of 5 and a y-intercept of 6. Okay, that's simple. We know the slope and the y-intercept. That's two things we have to have for this slope-intercept form. We have to have the slope, we have the intercept. Two things we got to have. Well, we got them. We got the slope and we got the y-intercept. So this is going to be y equals 5x plus 6. That's it. Well, number 2. Slope is 1/2. The y-intercept is -2. All right, again, we have both things we need. Two things we got to have: the slope and the y-intercept. We got both of them. So my equation here is y equals 1/2 x, and that's a -2, so I'm going to put -2, and that's my equation right there. You have to have these two things, the slope and the y-intercept. Okay, now suppose number 3 here, you're told that the slope is 4 and it goes through this point. 5, 7 goes through that point right there. We have one of our two things right here, the slope. We just don't have the y-intercept. So what we're going to have to do is we're going to have to figure out what the y-intercept is. So far I know this, y equals 4x, but I don't know the y-intercept number, so I got to put the b here. Well, what I'm going to do is I'm going to take this point it gives us, and I'm going to plug these values in for x and y. See, this is my x value, this is my y value. So I'm going to put them in down here. So 5 goes right here where x is, 7 goes over here where y is, and it looks like this. Okay? Now do a little multiplication right here. So 4 times 5 is 20. Okay, and then I'm going minus 20 on both sides, and then look here, 7 minus 20 is -13. There's my y-intercept right there. So there's my slope, there's my y-intercept. That's the two things I have to have. So my equation, y equals 4x minus 13, and there's my equation right there. There's my slope, and there's my y-intercept. Okay, I'll do another one like that. Okay. Number 4, the slope is 1/2, and it goes through 4, -3. Okay. All right. So again, we know the slope, so I know it's y equals 1/2 x. It's always the slope number times the x. But now I don't know the y-intercept, so I'm going to have to do this plus b thing again. And I'm going to take this point, this is my x, this is my y, and I'm going to put those values in to figure out what the b is. So 4 goes right here for x, -3 goes over here for y. So it looks like this. So this is -3 equals 1/2 times 4. Do a little multiplication right here. 1/2 times 4 is 2. Okay, and now a -2 on both sides to make this go away, and that's -5. There's my y-intercept. So there's my y-intercept, and there's my slope. So I've got the two things I need, the slope and the y-intercept. So my equation is y equals 1/2 x minus 5. There's my equation in slope-intercept form. Okay? Now, what if you have 2 points? Like number 5 here. What if you have these 2 points here? 3, 7, 6, 2. What's the equation line that has these 2 points? All right, well, we've got to have the slope and the y-intercept, those two things. We don't have either one of them. We don't have the slope or the y-intercept, neither one. So we're going to have to figure out both of those. Well, the slope, we've been doing it already. The slope is going to be the y in point 2 minus the y in point 1 over the x in point 2 minus the x in point 1. So this is going to be negative 5, and that's going to be a 3, and there's my slope right there. So there's the slope. Okay? So I know it's going to be y equals negative 5 over 3x plus b. I need to figure out the b just like we did the previous 2 problems. Okay? And now here I've got 2 points. I just got to pick one of these 2 points and put them in. Well, I'm going to pick this one because the numbers are lower. I could use that one, either one, but I'm going to take 3 and put it for x. I'm going to put 7 over here for y, and it looks like this. Okay? Now, right here, you got to do this multiplication. This is not hard. All you got to do, you do negative 5, divide by 3, and then times by 3. Okay? Negative 5, divide by 3, times by 3. And that comes out to be negative 5. I'll punch this in and get negative 5. Here, let me get a calculator, and I'll show you real quick. All right, see my calculator here? If I type this in, where's that person, you see it? So I'm going to do negative 5 divide by 3 times 3. See there? It comes out to be negative 5. Okay? All right, so I'm going to add 5 to make this go away, and b equals 12. There's my y-intercept. So there's my slope, there's my y-intercept. So that means this equation is going to be y equals negative 5 over 3 times x, and then plus 12. There's my equation of the line. Okay, now just for your benefit here, suppose I'd picked this point to put in instead of that point. See, I put 3, 7 in. What if I put 6, 2 in? Well, I'm going to do that. I'm going to come here and do that. I know it's y equals negative 5/3 x plus b. See, I know that because that was my slope here, negative 5/3. All right, so what if I put 6 in for x and I put 2 in for y? Okay, what if I did that? Now, if I type this in, I'm going to type it in for you this time so you can see it. I'm going to do negative 5 divided by 3 times 6. And look at there, negative 10. All right, so 2 equals negative 10 plus b. I'm going to add 10 to make this go away. Now I get 12 is b, which is with the same exact thing I got over here. See that? So either way, it don't matter which point you pick. When you find your slope, you got to take one of those points and put it in, and it don't matter which one, you're still going to get the same intercept number. Now, if you don't, you've made a mistake somewhere. Okay, so that's how you find the equation of the lines. Now, there is one extra thing you got to watch out for. Remember we talked a while ago about zero slope? We talked about undefined. Okay, if you have one of these, if your slope comes up to be 0, remember that's horizontal. So, suppose you have 0 slope, but it goes through this point right here, 5, 4. Okay, now a horizontal line, if you look at it, here's a horizontal line right here. It's counted by the y-axis. Okay, it tells how far up the y-axis it is. So this one, it's 4 up the y-axis. So this would just be y equals 4. This will be my equation of the line right here. Okay, so if I draw this one, 1, 2, 3, 4, 5, 1, 2, 3, 4. It goes through this point right here, but it's horizontal because it has 0 slope. Well, you can see it's y equals 4. 1, 2, 3, 4. Y equals 4 on that whole line. Now, if it's undefined, that means it's vertical. So suppose I have this one here. It's undefined and it goes through 2, 1. Okay. Well, 2, 1 is this point right here, and it's undefined, so it's a vertical line like this. Okay, well, you count it off on the x-axis. So this is x equals 2, and that would be my equation there. So these are two cases you have to watch out for. If you have 0 slope, which is horizontal, it's going to be y equals a number. And if you have undefined, which is vertical, it's going to be x equals a number. Okay? I think we have one here. Yeah, look here. This problem here, number 14. The slope is undefined. It passes through this point right here. There's one of the problems right there. Let's do it again. I'm going to make up another one. Undefined, and it passes through -2, -8. Okay, it's undefined. It's going to be x equals a number. Well, here's my x number right there. This is x equals -2, and that's all you do. It's real simple. What about if it's undefined and it goes to this point here, 9, 12, goes to that point? Well, it's going to be x equals my x value there, 9. Okay. Well, if you have a 0 slope, and it goes through this point right here, 2, 8. All right, 0 slope, it's going to be y equals a number, which is my 8 here. So this is y equals 8. And this would be the equation of that line. So when you have these special cases where you have 0 slope and undefined slope, it's always going to be y equals a number or x equals a number, depending on if it's a 0 or undefined. Okay? Now, back to what we were talking about a while ago. These lines we've been talking about all this time are slope-intercept form. Well, standard form looks like this right here. Now, all we're going to be concerned about on standard form is changing from this form to that form. So let's look at this one right here, number 1 here. Let's change it to standard form. See this line right here? That's slope-intercept form because you got y equals your slope times your x plus your y-intercept number. What would that be in standard form? So let's write it down right here. First thing I want to do is I want to get my x's and y's both. See, my x's and y's are both over here on this side of the equals. So on this one, see my x, here's my equals. This needs to go over to the other side. So I'm just going to minus 5x. Okay, now my x's are first and then my y's. So on this one, my x's will go first. I can't put them together because they're different. So I got -5x plus y equals 6. So there you go. We're all in the right places, but here, see, here's the thing. A is always positive, and right here my a number is negative. So to fix that, I just change all the signs. So -5x turns into 5x, plus y turns into minus y, and then 6 turns into -6, and there it is in standard form. Okay? Now suppose we have this one here, y equals 1/2 x minus 2. Okay, well, first thing, see, I got this fraction. I can't have any fractions. So what I do is I'm just going to go ahead and get rid of the fractions by multiplying by the common denominator. And I just have 1 here, this 2. So I'm going to multiply everything by 2. So 2 times y would be 2y. Over here, 2 times 1/2 would be just 1x. 2 times -2 would be -4. And there you go. I got rid of all the fractions. There's no fractions now. Now I can move my x. So I subtract x on both sides, which gives me -x plus 2y equals -4. See, my x's go away now. Okay. And then my x is negative again, so I have to change all the signs because the a number can't be negative. So this is going to be a positive x. That's going to turn that to minus 2y. That's going to turn into a positive 4. And there's my equation in standard form. Okay? So in standard form, there can't be any fractions, and the first number, the A number, has to be positive. Okay? Let's change one more of those we did just a minute ago. Where's it at? Okay, here you go. This one right here. Let's change it to standard form. We'll see how we got this fraction, -5/3. I'm going to multiply both sides by 3 to get rid of the 3. So 3 times y would be 3y. 3 times -5/3, just use your calculator, -5 divided by 3 times 3 would be -5x. And then 3 times 12 would be 36. So I do 3 times everything. 3 times y, 3 times 5/3, 3 times 12. Okay, so then I add 5x to both sides to make this go away. Now that gives me a positive 5x, put the x first. That's a positive 3y, put that second. And over here equals 36. And there you go, we're done. This is standard form because there's no fractions. We've got our x's and y's both over here. This is positive, so we're in good shape. Okay. All right, so on this assignment, here's one. Let's do 19 here. Okay, see this is 3/4 x. I need to multiply both sides by 4. Okay. All right, so when I multiply by 4, 4 times y is 4y equals. When I multiply over here by 4, 3/4 times 4, with 3 divided by 4 times 4 is 3x, plus 7 times 4 is 28. Okay, so multiply by 4 here, 4y, multiply by 4 here, which is 3x, multiply by 4 there, 28. And now, remember my equals here, x and y both have to be on the left of the equals, so the minus 3x here, to get my x's gone from here, and now I've got a negative 3x, I got a plus 4y equals, over here I got 28. And they're all in the right spots. There's no fractions, but we do have the a number here's negative, so I have to change all the signs because he can't be negative. If he was positive, we wouldn't worry about it, we'd be done. So I got to change him. I change him to positive 3x, change it to minus 4y, and I change this to negative 28, and then there you go. There's my equation right there. Okay? All right, so that's a little bit about slope and linear equations. If you have any questions, you need to contact me. Go ahead anytime, and I hope you have a good rest of the day. Bye-bye.